Section 2.6 is talking about solving equations with sign numbers. So we did expressions earlier. So equations are the same sort of thing we said about expressions. When you solve equations with sign numbers, it's not different from when you were doing equations that didn't have sign numbers. You're still going to use the do, undo, or as I usually say it, done, undo procedure as before. But just like with expressions, you just have to be extra careful because of the sign numbers. It's easy to make sign mistakes. So take a simple equation like this one up here, negative 5x equals 30. So what was done, and the way we've been doing it in class, is using sort of shorthand. So, but be careful when you write that to know what you mean. So I'm multiplying by negative 5. Maybe we should put it in parentheses. And then, so undoing it is going to be the opposite operation. I'm going to divide by negative 5. So to solve that, I have my original equation, minus 5x equals 30. So remember that when you do this done undo thing, the power of it, the reason we ask you to do this, is that you then take this, and this side of the chart just tells you what to do. Once you've filled out the chart, you don't have to think very hard. You're just following your own directions. And your directions say divide by negative 5. So you're going to take both sides of the equation, divide by negative 5. These negative 5's cancel out, and I have x equals 30 divided by negative 5 is negative 6. So this is my answer. It's my solution to the equation. Now, one thing I noticed on your Module 1 tests is that frequently people are hesitant. Well, so first of all, some people don't use the done undo process, and they get themselves in trouble that way. So I want to really strongly recommend that you use that done undo chart. And if you're not sure how to do it, ask questions, watch my videos, ask at the math angle, make sure you know how to do that. It really helps people keep these things straight. The other thing is that when I grade Module 1 tests, I always see that people are a little bit unclear on checking things. And so all we mean by checking is we take our original equation. So checking is going to be like we did in the previous video about plugging things into an equation. I'm going to take that, where the x was in the equation, and put a parentheses. And then to check it, I'm going to stick what I claimed the solution was, which was negative 6 in there, and I'm going to ask whether this is true. So then negative 5 times negative 6 is 30, and sure enough that's equal to 30, so that means I checked it. Now sometimes people get confused about that and say, oh, the answer is 30. No, the answer is not 30. Your solution was up here, x equals negative 6. We checked it, and just because of the equation, the way it's written, happens to come out 30 equals 30. We don't really care what these numbers are. We care that they're the same. So it has to be 30 equals 30. It can't be 30 equals negative 30 or anything like that. It's got to be the same numbers. But those numbers themselves are not necessarily significant, so don't get confused and think that's the answer. Okay, so here's a two-step one. Negative 7x plus 3 equals negative 32. So we look at what was done to the x. The first thing is we multiply by negative 7, and then we added 3. So it's another place where people get confused sometimes. Remember that what you do is do the opposite operations in the opposite order. So this plus 3 goes up here and becomes a minus 3, and then the times -7 becomes a divided by -7. And then remember that this little box just becomes your set of directions that you made for yourself about how to solve it. So don't do that box and then go reinvent it. Once you've done that box, all you're doing is following what you told yourself to do there. So I have my original equation, put the parentheses in for the x. Oops, I'm doing the check thing, that's not what we want to do. We're going to put the x in there. So now I'm going to undo the way my set of directions say to do. So they say to subtract 3 first, both sides of the equation. So then I end up with -7x equals -35. My next step here says to divide by -7. So I'm going to divide by -7 and get x equals +5. So that's my solution to the equation. All I did was follow the steps that my table that I made told me to follow. Now remember, if I'm going to check, this is when I put my parentheses in for the x. Now I claim that x equals 5, so I'm going to put 5 in there, put a question mark over there, -35 plus 3, and we're asking is that equal to -32. -32 equals -32, so we know we're correct. And remember, -32 is not the answer. What's important is that those two numbers are the same. The answer is still, the solution is x equals 5. I'm putting this one in because sometimes people get a little confused by division when it's put in this way. So this is my equation, t divided by -5 plus 14 equals 17. So what was done to the variable is first we're dividing by -5, and then we're adding 14. So to undo that, we're going to subtract 14 and multiply by -5. So I put my original equation in here, 17 equals t divided by -5 plus 14. Remember, I'm just following these. Once I've written this out, this is just my set of directions that tell me what to do. So it says subtract 14 first. So I get 3 equals t divided by -5. Now it says my directions say multiply by -5. So I'm going to multiply by -5, multiply by -5, and I get -15 equals t. And that's my solution. And to save us a little time, I'm not going to check this one, but don't follow me. You should always check it. I just want to save us a little time on this video.